Okay. So what are we going to learn today? That is the question. And in the group, I mentioned this, that we are going to talk about transformational geometry. 200. Yeah, it's right in front of you. I'm sorry, what? Yeah, it's for you only. So here's the thing. For all the kids, I have notebook and pencils here. So there are some notebooks here. Whenever you come without preparation, you can just grab it from here. Yeah. Yeah. Okay. Hello, Sundara. Hi, Gayatri.
Hi, sir.
Hello. Hi, Lunch. So lunch is a little.
Do you have a pencil sharpener?
No, you can pick a pen or something. That goes. So Lux is a very interesting personality. Okay. Sometimes Lux joins level 1 class, sometimes level 2 class, and he keeps enjoying both the classes depending on what goes best for him. And that's perfectly fine. I don't actually worry about it because who all has watched the movie 3 Idiots? So my question to you all is, who all has watched the movie 3 Idiots? So everybody has watched 3 Idiots. In that movie, I mean, if somebody has not watched, just to let you guys know, this movie was about 3 friends, and one of the friend he was very carefree guy, but very intelligent guy. He always believed that there's nothing that you have to study. It's about the knowledge that you acquire. You don't study for getting score. You learn things to enrich your knowledge. Okay. No matter whether you are sitting in class A, class B, class C, as long as you are learning, your purpose is fulfilled. And I see Lux is enjoying that. So it's perfectly fine. There's nothing wrong with it. All right. Sorry, is also here. So one thing before we get started, today is the last class of this year for the kids who are meeting me on weekends. So last class for this batch of this year. We'll take a break of 1 weekend. So next weekend we are not meeting, and then we are meeting again on 3rd of January. Starting 3rd of January. Kids who are having classes on Monday, Tuesday, and Wednesday, we'll have classes on Monday, Tuesday, and Wednesday. So we are meeting tomorrow for sure. We'll have classes on Tuesday, that is for the kids. And Wednesday we'll have the pre-calculus class, and after that, I will go in a hibernation mode for a week. Nobody will get to even see me where I am. I'll disappear. So, let's get started. What are we going to learn today? We are going to talk about transformational geometry. And what exactly does it mean? Transformational geometry. Does it ring the bell for any of you? What is transformational geometry? Anybody can describe it for me, please? Anybody, please? I totally forgot about it. Somebody has to help me. Anybody? Nobody? Okay. How about you, sir? Have you come across this term before? No? Okay, that's a good news. Vasundhara, Gayatri, anybody? Sami? Sohina? Nobody? You don't want to help a teacher?
No, sir.
Your teacher is stuck in a situation where he doesn't know what is this, and nobody is coming to my rescue. Okay, don't worry about it. I was just kidding. Hello, Sarvita. This is a triangle lying in the coordinate plane. Yeah. What I'm doing is, I'm trying to shift this triangle by 2 points. Meaning, this moved by, let's say I moved it by a few points such that it came here. What I did was I shifted this triangle by this many points. Or I lifted this triangle. Meaning each and every vertices of this triangle got shifted by a certain number of points. Everything shifted by, let's say, 3 units. This vertex also shifted by 3 units. Okay? This is called translation. When you move the entire shape without distorting it by certain points in any direction, be it shifting it right, be it shifting it left, be it moving it up, be it moving it down. This is called translation. Okay? So, for the kids who have joined just now, we are talking about a unit called Transformational Geometry. Okay? So far we have talked about geometry where we talked about different shapes. Now we are talking about transformational geometry, meaning you are transforming the geometry or geometrical shapes that we have talked about. So I started with the first shape, which is a triangle. I am just moving it. I moved it to the right. I moved it to the above. So whole thing shifted by certain points. I can move it down also. In all the circumstances, what you are seeing is my whole triangle as a solid entity, as a rigid entity, is moving this way, this way, this way, or might move this way. This is called translation. And I use the word rigid, meaning my shape is rigid. The shape is not changing at all. Okay? So there are 2 types of transformation we talk about. One is called rigid transformation, one is called non-rigid transformation. So here we are talking about rigid transformation, and that too within transformation a form called translation where I am just moving it. Okay? Now imagine that I did not move the triangle. Okay? What I did was I took the triangle. Let's say this was my triangle. I fixed this point, meaning I nailed it here, okay? I put a nail here so that this guy doesn't move. And then I rotated it by 90 degrees. Okay? So my triangle became something like I just rotated it. In the earlier case, I was shifting this. This time I did not shift it. I fixed one of the vertex and then rotated it by 90 degree in anti-clockwise direction. I can rotate in the clockwise direction also. And this will be your shape if I am rotating it this way. Okay? So this is also another form of transformation. First one was translation when you were moving it above, below, or laterally. This is another form called rotation. And again, for rotating it, you have to fix one corner, right? Or you can say, okay, my center of rotation is here, and then I am just moving this triangle, keeping this center in mind. So here, triangle is rotating from here to here. Then triangle is rotating from here to here. So you can rotate it against one of the vertex or against the center. Okay? Okay? So translation is lateral or vertical movement. Rotation is when you rotate the triangle against a vertex or against the center. Now, there is a third situation where you are reflecting, meaning I will say I will take a mirror image of this and flip it upside down. So we did not move it, we created a reflection of that. So these are 3 forms of translation or 3 forms of rigid transformation. Meaning where you're not distorting the shape, you're just moving the shape in its form without anything being changed. You are either moving it horizontally, vertically, or you're rotating it, or you're creating a reflection of that. These three forms of translation are called rigid transformation. Be it translation, be it rotation, or be it reflection. Does it sound okay? Yeah? Okay. Now, there is another form called, are you feeling very hot? No? Alright, because sometimes I'm feeling two of the heaters working together, sometimes I'm feeling hot. Alright. Second form is non-rigid transformation. What does it mean? It's not rigid, meaning the shape is changing. If I, let's say, this triangle that I had, I pushed this corner and the triangle became like this. From here, this vertex shifted this way. The dimensions are changing. This is called dilation. Okay, meaning when you are transforming the shape where it is not rigid in nature, meaning its original shape changes, that is called dilation. Are you guys okay so far? Yes, Laksh.
I don't understand why would not be like rotation, because it's shifting the shape around the cone.
So see, this is not rotation because this is not rigid. In case of rotation, it is called rigid transformation. Meaning your original shape remains intact. What is happening here is your original shape. This was let's say, an equilateral triangle. This is not an equilateral triangle anymore. This side became bigger. You distorted the shape. Okay? So that's why it is not rotation. It is non-rigid translation. Rotation is rigid in nature, meaning your shape is not changing at all. You are just moving it from one place to another. You are rotating it. It's going upside down, whatever it is. But your original shape remains intact. In this case, your original shape is not preserved. It is changed. That's why it's called non-rigid transformation. Yeah? Does that make sense to everybody, or I am not being successful yet? Sammy, Suhina, Milana, Tasvik, everybody? Gayatri, Vasundhara, sorry, everybody?
Yes, sir.
Okay. So, this was the theory part of it. The summary of whatever I said so far is simple. That in this unit we are talking about transformation. And the transformation could be of two types. One is rigid transformation, second is non-rigid transformation or dilation. When you talk about rigid transformation, you are keeping the shape intact. You can move it, but you are not changing it. You are not changing the dimension of the shape. Okay? You can rotate it, but you are not changing the dimension of the shape. Okay? Whatever was, let's say, 4 centimeter in length, that remains 4 centimeter only. Okay? Whatever was the angle before, whatever were the angles before, that remains the same. The original shape is intact. So, be it translation, be it rotation, be it reflection, these are the rigid forms of translation where the original shape remains intact. Non-rigid form is where your shape distorts. Okay? Now let's look at some legitimate problems relating to these concepts to be able to appreciate what is that would come into play when it comes to these concepts. With my limited skills, let me draw two triangles A and B. This question says, what single transformation was applied to triangle A to get triangle B? And you have 4 options: translation, rotation, reflection and dilation. Sammy said something to the viewer, but I cannot hear. Yes, better. Unmute yourself and tell me.
I think it's reflection.
Reflection. Okay. How about Lach?
I also think reflection.
Reflection. Okay. How about Arihan?
Reflection.
Rotation. Suhina?
Reflection.
Reflection. Tasvik? Dikshita?
Reflection.
Reflection. Sanvita?
Rotation.
Rotation.
I think it's rotation.
You also think it's rotation? So, okay. I'm a little confused between reflection and rotation. I know I did not do a great job with my drawing skills, but look at this one. When I'm rotating it from here to here, this side is almost like a right angle, okay? If I'm just rotating it, it will not become like this. And if you think about this, when I'm taking a reflection at this one, this side, the longer side will come this way. So that's why I'm leaning more towards reflection for this compared to rotation actually. Because if I just rotate this one, this is the, look at it, this is a shorter side. If I rotate it, it will not come here. If I rotate this guy, the longer side will come here. But in this case, it looks more like a reflection scenario to me. Yes, Lach.
And also, it won't be rotation because it's not like rotating around a single point.
Yeah.
It's not around a single point.
Right. So rotation could be two scenarios. Okay. As I said, one is rotating against a single point or rotating against the center. So if this is my center of rotation, okay. Let's say I'm gluing this triangle with a string and then trying to rotate. Even if I'm rotating it, this side's length will not become shorter. That's why it looks more like a reflection case to me. Does it sound okay to you guys or? Yep. Sami, Suhina, Dikshita, Arihan, everybody okay?
So can you repeat that?
I'm sorry, Vita?
Can you repeat that, please?
Okay. So the choice is between rotation and reflection right now. Okay. Translation we are not talking about because it doesn't look like a case of simple movement. Yeah. Rotation is done against two parameters. One is, or under two circumstances. One is when I'm fixing one point and then rotating it, which is not the case here. Or second case of rotation is you are rotating it against the center, meaning I have a string, I got this triangle glued to it and then I'm rotating it. Here in this case, this side is looking to be the longest side and this is the medium length side. Here also this is the longest side, this is the medium length side. If I am just rotating it, this side will not come here, this side should come here, meaning the side next to this should be the longest side, then only I am rotating it, right? But that is not the case. If I think of this as a mirror image, when I took a mirror image, this side will flip and come here, right? That's why it's looking more like a case of reflection to me. Hope I'm making sense to everybody who were thinking otherwise.
Yes, sir.
Milana, Gayatri, Vasundhara, everybody okay? Are you okay, Myra?
Yes, sir.
Okay. Alright. Okay. Suhina, you are not well, I heard. I take good care, okay? And if you feel a little stressed out, let me know, okay? Let's move on to the next problem. Suhina, you are saying something, Peter? Okay. Let's go to the next problem. Remember this. There are only two types of transformation. One is called rigid transformation, one is called non-rigid transformation. In case of rigid transformation, you are not changing the shape, you are only moving the shape, either rotating it, taking a reflection of it, or laterally or vertically moving it. If you are talking about non-rigid transformation or dilation, that is when you look at changing the dimension of the objects that you are talking about. So now, okay, I have two shapes A and B. What single transformation was applied to the quadrilateral A to get to quadrilateral B? And the options you have are translation, rotation, reflection and dilation. What do you think, it's a
I think it's
dilation? Okay. Venkata Kishore P. Is that you, Thiru? I'm sorry?
It's the options again.
I'm sorry?
Can you repeat the options again?
The options are rotation, dilation, translation and reflection. Okay. So Venkata Kishore, is that Thiru and Swari? I'm sorry? Oh, Nihan. Okay. Sorry. I was wondering. Arihan, what is that you're leaning towards?
Translation.
Translation? Laksh?
Dilation.
Dilation? Sanmita?
Dilation.
Deechita?
Translation.
Say that again, beta?
Translation.
Okay. Aryahi, Maya, Vasundhara, Tasvik,
I think it's translation.
translation.
So can you repeat the options?
Options are rotation, dilation, translation and rotation. Aryahi,
I think it's translation.
translation. Vasundhara,
I think it's dilation.
dilation. Sami.
I think it's dilation.
Okay. So here's the thing. The answer is dilation. As I repeated in the beginning of the class also, that there are only two types of transformation. One is rigid and one is non-rigid. Non-rigid one is called dilation, meaning when you are changing the shape, when you are changing the dimension, when you are changing the dimension, be it by changing the shape or be it by distorting it, by breaking into pieces, whatever you do, the original shape doesn't remain original. In case of rigid transformation, there are three scenarios: rotation, when you are rotating it without changing the shape, or moving it laterally or vertically, or you are creating a reflection of it, meaning as long as the original shape is kept intact, it is rigid transformation. If the original shape gets changed, look at this A and B, even if my drawing skill is horribly bad, but nobody would dare to say that these two are same. Correct? These two are not same. And if it is still not sounding convincing, let me try being more explicit. Now at least that element, the smallest element of doubt that anybody had, that is diluted. This is not a translation case. In case of translation, your original shape remains the same. This is not translation. This is not rotation either. Your shape is changing, the dimensions are changing. Be it scale up, scale down, be it distortion, but the shape is changing. So this is not rotation, this is not translation, this is not reflection. It is dilation. Alright? Now let's go to the next problem. let's go to next problem. Next problem is that's the reason why I don't look at my phone during the class. If I do so, I get distracted. Now this is a good interesting problem, okay? I want everybody to pay full attention to this question so that you are able to deal with it better. Now read, hear the question. Point Q is point Q dash is the image of Q minus 8 comma minus 3 under translation by 4 units to the right and 5 units up. Point Q dash is an image of Q under translation by 4 units to the right and 5 units up. What are the coordinates of Q dash? And you have to fill this. The x coordinate is here, y coordinate is here. These are 2 boxes that you have to fill. Did you guys hear the question clearly? Let me repeat it one more time. Point Q dash is the reflection of this point Q, minus 8 comma minus 3. Under translation by 4 units to the right and 5 units up. And you guys have to find out the coordinates of Q dash. Like you have minus 8 comma 3, you have to find out what are the coordinates of Q dash. Yes, Lux.
Negative 4 comma 2.
I got the same.
Negative 4 comma 2. Okay. I'm not saying yet whether that is correct or not. I'll give everybody else 30 more seconds to fill my water bottle. I'll be back. You need water bottle?
No.
Okay. I'll just fill it from it. Okay. Aryahi, Vasundhara, okay, Sangeeta, tell me what did you get?
Negative 4 and 2.
Negative 4 and 2. This is what Laksh also got. This is what Ipsha also got, right? Okay. How about Sami, Deekshita, Milana, Hiranya, Deekshita, go ahead.
I thought the same thing, sir.
Negative 4,2. How about Vasundhara? Yes, Nihan.
I thought the same thing. Negative 4 and 2.
Yes, Shabita. Ilana, go ahead. Okay, Sharia, how about you? Yes, Vasundhara.
Negative 4.
Negative 4 and 2. Sharia, how about you, beta?
I got negative 1 too.
Okay, Myra.
I thought negative 4 comma 2.
Negative 4 comma 2. Now I don't know whether that answer is correct or not. So you guys are all running with a very high risk of all being right or all being wrong. Let's see. Let's see how legitimate is the risk. Q dash we have to find out which is reflection of this by translating it by 4 units to the right and 5 units up. This is my coordinate plane 4, 8, 12, minus 4, minus 8, minus 12. 1, 2, 3, 4. Minus 1, minus 2, minus 3. Okay. My current point Q is minus 8 comma minus 3. So minus 8 comma minus 3 here. 4 units to the right, it comes to this point, minus 4. And 5 units up, right now it is at minus 3. 5 units up will cross this x-axis and go all the way to this point. So this point's coordinates are 4 units to right. So minus 8, it came to minus 4, as you guys said, and 2 on the y-axis. So you guys got it right. Thankfully, nobody went wrong. It was not that difficult to read. But see, the point is, here what we saw was how is this point translating from here with this one. This point translated from here to here. The point did not change. The point did not change its shape to become a balloon. It remained a point. So it's a rigid translation or rigid transformation. Now let's look at one more point. One more question. This question says, point the image of a point P under translation by 1 unit to the right and 8 units up. This is going to be a cakewalk for sure for you all. So I will just, let me not do this one, okay? Let me cook up a problem for you guys on the fly. I have a triangle here, okay, with the coordinates 2, minus 2, 2, and this is 8, 2, and this is 6, 6, 10, that's it, okay. I am rotating this triangle, fixing this point, okay. I am rotating this by 180 by 90 degree. I am rotating this anti-clockwise by 90 degree. Find out the coordinate of this point B and find out the coordinate of this point B after the translation. So I have a triangle AB, let's say this one, this is A, B, and this is C, okay. I fixed up this point and rotated this triangle by 90 degree. I am asking you guys to tell me what is the coordinate of this point after the translation or after the rotation. And that will be the last question of the day, last question of the year, last question of the week for most of you except Aryahi, Ifsha, Moira, Samvita, Vasundhara. Yeah. Who are meeting me again tomorrow. Everybody else, for you all, this is the last question of the week or the month or the year, except the names I called out. Everybody have the question, right? I have a triangle ABC, the coordinates are given here on the screen. I fix up the point A, which is right next to the finger that I put here, and then rotated this triangle counterclockwise. I'm asking you after the translation or the rotation, whatever you call it, what is the coordinate of point B? What is the new coordinate of point B? Everybody clear to the question, right? Vasundhara, Sanvita, Dikshita, Saurya, Hiranya, Gayatri.
Yes, sir.
Okay. Dilana, Adya, everybody clear? Adya clear with her? Okay. So, see here, when you guys don't talk, sometimes, I remember during my college days, I will not go to the class, I will ask some of my friends to do proxy for me. I hope nobody is doing proxy here by logging in with somebody's name and without speaking out, they're just saying, yeah, I got it. Sometimes when I hear your name, I would know that, okay, nobody is doing proxy for you. I'm just kidding. Nobody will be super excited to do proxy for the class for sure. Just asking. Okay, I'll give you guys some peace of mind to solve this and bother you guys after 2 minutes. Are you able to think?
I get the question, I just don't know how to do it.
I'm sorry, Rita?
I get the question, I just don't know how to do it.
Okay. You have to visualize. Create a picture in your mind. Yes, Sanita.
I got negative 2x and then 8y.
Say that again. Negative 2,
And 8.
8.
Wait, is this a
Yeah.
trick question? Because if you rotate, wait, what point are we finding?
We are trying to find out the coordinates of point B. I'm rotating it counterclockwise. So going against the way a clock moves by 90 degree.
Okay.
Okay. Vasundhara, what did you get, better?
I got 2 and 8. 2,8.
2, 8. So you got 2, 8. Okay, we'll see.
Okay,
Yeah.
I got 6 comma 2.
Okay. 6, 2 is also not the option. Okay, we'll see. Lux, what did you get?
I got 2, 8.
2, 8. Arihan,
Wait, I'd like to change my answer. I'd like to change the 2 to 4.
say that again.
4.
4. This one?
No, the 2
Uh-huh.
to 4.
2, 4. Okay.
No, not 2 comma 4, 6 comma 4.
6, 4. Okay. Okay, Arihan, what did you get?
Negative 2, 10.
Negative 2, 10. Okay. How about Adya, Aryahi, Mara, Bilana, Hiranya, Dikita, Sami? Yes, sorry.
I got 2 over 8. 2
2,
comma
2, comma
2 comma 8.
8. Okay. Aryahi,
I also got 2, 8.
Mara,
I got 2, 8.
Dikita,
I got 2, 8.
Bilana,
Sorry, I just came back from the bathroom.
Oh, okay. So here's the thing. As I was saying that this is the last question of the week, of the month, of the year for most of you, except for the kids who are meeting me tomorrow for the Algebra 2 class. Okay? We are talking about a transformation which is rigid in nature, meaning we are rotating this triangle. What will happen is, I am saying that okay, I am keeping this coordinate fixed and rotating this guy. So rotating by 90 degree. So this base AB, this became by B dash. Okay? I'm just giving a name. And then this C will come somewhere here. So my base moved from here to here. And this point remained 2, 2. A did not change. Only B moved from here to B dash. C moved from C to C dash. Okay. Now look at this. this was a horizontal line because 2 comma 2, my y value is 2 here and here also y value is 2. So this is a horizontal line. So this became vertical line by rotating by 90 degrees. So this point's x coordinate will remain 2, same. What will the y coordinate changing to? So this length from here to here was how much? My y coordinate was fixed, it changed from 2 to 8, that is this length is 6. So distance from here to here is changing by 6 units. So 2 comma 2, my y value will increase by 6 points. So from it becomes 2 comma 8. 2 here and 6 units here, which is the length of this side also. So it became 2 comma 8. Yeah? Does it make sense to everybody? Yeah? So, now I was not wanting to end this class abruptly, but I don't have any Christmas gift for you guys. So this is the only gift I could offer you guys. Okay? I'll have something for Isha because she's in the classroom with me. So obviously I'll get her Christmas gift, maybe some candies. No? Okay. But for you all, my only Christmas gift is I'm giving you guys 20 minutes of your precious time with family so that you can enjoy the rest of your evening and have fun. Make sure that you get the best out of Christmas and New Year for you all. Convey my best wishes to your family members and we'll continue with our journey of learning math in the New Year as well. Thank you so much for even trusting me as a teacher because I never thought that I have the ability of teaching kids. But when I was teaching my own daughters, I started realizing that okay, I think I can do a good job. I can do decent. So that is how I started 2 years ago. I'm still teaching the kids back in India and I will continue teaching you guys because I'm enjoying it. So we'll continue with our interesting journey of math and whenever there's any problem anything that is bothering you, any question that comes to your mind that you're not able to address by yourself or if you know how to solve some problem but you don't know if that is the best approach or not, always feel comfortable, ask questions, send it to me and we'll try working on it together. Make sure that our learning of math remains as much fun as possible because if you are learning it because your parents have asked you to join this class, you will not enjoy it. You will enjoy it if we are having a good connection among us and we trust each other for ensuring our ability to learn things. Okay? With that being said, I'll let you guys go. No, I don't have any speech prepared for the class today. See some of you tomorrow who are part of my Level2 class. And everybody else, I don't exist for you guys for the rest of the year. Apart from the video I will upload and then catch hold of everybody in the new year with more energy, with more passion, with more fun with math. Alright? Have fun guys. Enjoy.
Thank you and happy New Year. Bye.
Alright. Bye bye. Bye bye. Take care. Bye bye. Bye bye. Okay. So that brings us to the end of the class. Now